All right, well, today we are doing old school tide calculations. So we are going back to the book of how our fancy tide programs and stuff actually calculate the tides. My printer was not working this week. I need to get a new one. But you should have a handout of like, I don't know, 10, 20 pages or something. How many pages is it?
The one with the tide tables on it?
17 pages, yes. And that's the 2021 tide tables. So that's our reference that we're going to be looking at today. I don't know if anyone has gone down to OCC and gotten a little tide book. Obviously, this one's an old one, but this is also a great little pocket guide to use, and we'll talk about what this is, but you can usually get them at other, like West Marine, and those places will have it too. Okay. So any questions before we start? We're gonna get going. Dive right into it. Hopefully have enough time. Okay, it's good.
Tide book.
Okay, so we're talking about tides. Here in Southern California, our tides aren't crazy. Our tidal range, remember our tidal range is the difference between a consecutive high and low. So it's kind of that difference. So here we don't have like a huge difference where your boat's going to be floating versus not floating, but in other places around the country and the world, they do. So what is a tide? Kind of going back to our week one here, it's the vertical movement of water. So we were talking about current, which pushes you one way or another. That's the horizontal. The tide is that vertical movement. And we're going to apply that number, whatever number we calculate, to the chart sounding. So whatever number the chart says, you know, all those little soundings, lots of different numbers, we're going to apply our tide uniformly to all of those numbers to get what the actual depth of water is. So we have a little equation here, if you will. Our chart depth plus the tide equals the actual depth of water. And then if we minus our draft, so draft is the amount of the boat that is submerged in the water, right? Then we get our under keel clearance. So that is what's kind of driving us in our navigating when we're looking at depths of water, is what are we okay with our under keel clearance? Are we okay with 10 feet? Are we okay with 3 feet? Are we okay with 20 feet? You know, what is our safe mark? You know, what do we think is safe? So that is up to you. And your comfort level of, you know, one, how well you trust your tide calculations, and two, how well you trust your instruments. You know, your fathometer should tell you your under keel clearance as well. Sometimes your fathometer isn't below the keel, so you have to do a little math there as well, or your little Doppler speed log thing, depending on what instrument you have on board. So we always want to, or I guess, yeah, the driving force behind basically our topic today is that underkeel clearance. We don't want to run aground. So we're going to be calculating the tide, but again, we apply our tide to our chart depth, and then we minus our draft in order to get that underkeel clearance, which is what, either we're running aground or we're not running aground. So does that make sense? Those terms I have here, chart depth, tide, actual water depth, draft, UKC. Okay.
Actually, did you see today where there was this giant freighter that ran aground in the Suez Canal?
Yes, and Lisa sent me a picture of it too. That was not a great situation.
Do you have a thought why that happened?
I did not look into it. I just saw a bunch of silly memes that were mean. But I didn't look into the actual event. Did anybody else look into that event?
The owner's saying wind. That's what the ship managers are saying, that they didn't take the, dramatic winds into account. But when you look at the satellite and you track the vessel, obviously other vessels were navigating the channel, or the canal, but obviously this is a very large ship and it has a huge profile. And so it's going to be vulnerable to winds. But I urge everybody to go on YouTube and just plug it in, and they'll show you sort of what the vessel was doing before it entered the canal. And then all of a sudden you kind of see it take a right turn just straight into the canal. And then you see what look like almost mosquitoes just running for it, which are tugboats and vessel assist boats that monitor the canal to try to figure out what happened. And then you start to see the ships that are just building up on either side of the canal. It's just a tremendous bottleneck.
Sure.
For those interested, there's really no liability for the delay it's causing to all those ships. So the only question is, whether the hull is damaged, whether, the costs of refloating it. And I don't know Egyptian law, but whether the cargo has claims for delay, because the vessel's now going to be a week off, right?
Yeah.
Bree, who's responsible for the accident? Is it pilot or is it the captain?
The captain.
Even though they're required to use a pilot when they go through the canal, that's not part of the shipping company?
Correct.
Yes. That pilot is there for advisement, not to maintain responsibility legally.
Okay. So the pilot doesn't actually steer the ship then?
It does.
The pilot is the one advising how to steer the ship, but the captain needs to be present, and the captain has responsibility of the actions of the ship, even though they're putting their faith in pilot.
Gotcha.
But the pilot is just there as an advisor role. Cool. Okay. Let's keep going here. Okay, another figure of our draft underkeel clearance description. Again, like sometimes your boat, if you're on a sailboat, the keel is probably not going to be, is going to have, a deeper draft than possibly your unit that is measuring your depth under your keel. So you'll need to know where that unit is if you're trusting that for underkeel clearance, and apply that margin of error if it is not at the deepest part. So again, all boats are different on this. Does anybody use this Doppler or underkeel clearance, fathometer, whatever you want to call it? Does anybody use one of those on board?
I do, and I always make sure that there's a lot of clearance.
Okay, so what is a lot to you?
At least, well, my preference, 10 feet.
10 feet. Okay.
You know,
Very
I just
good.
don't like to, you know, suddenly there's a rock, especially in powerboats, you're going pretty quickly, and there's no forward radar. I mean, they do have them now, but you have to be going pretty slow. And so I like 10 feet just in case there's a little rock.
Yes. And does yours have a graph readout as well that you can see it getting shallower or deeper?
Yes. It's an old one where it's only in the it's bow to stern. Now they have the side viewing one as well, which is really nice.
Oh, very cool. Yeah, so all depends on what type of instrument you have on board. So that's underkeel clearance. We also have vertical clearance or our bridge clearance. Most bridges will have, most bridges that are typically navigated, I guess I'll say, will have this kind of readout that will tell you the vertical clearance, which is really nice. But it's also, you know, very important to know the vertical clearance of your boat, especially if it's a sailboat. Do you need to take down the mast to clear this, or what is the vertical clearance of your boat to clear a bridge? So I thought this one was a cool picture. They put weight on the off the top to get it under the bridge, which was pretty clever idea. But those are the two things that are affected by tide, right? Our tide affects our bridge vertical clearance, and it also affects our under keel clearance. So we want to keep both of those in mind. You know, one of those is going to be kind of that limiting factor that we're worried about, depending on where we're going, what kind of boat we're on. So we got to calculate our tide. Okay, so our tide tables are annual, published annually, part of the Nav Pubs system. They're published by NOAA, NOS, the National Oceanographic Service. Yes. But you can also get them online. I was actually just trying to get the 2021 online, the full volume 3, and I could only do each reference station individually, and that would take a long time to download. So I need to figure out how to do that for you guys. But there's the 2021 from last year. Yeah, okay. NOAA publishes volumes 1, 2, 3, and 4. So volume 1 is our Europe, Africa. And so it covers, you know, the whole East Coast, North and South America, East Coast, North and South America, West Coast, and then the Pacific region. So it does cover a lot. We're looking at volume 3. And if we look at our table of contents, we have 9 tables. We're only going to be using 3 tables for this class. And for the majority of it, you really only use 3 tables. But that's how this publication works. It puts things in tables, and we want to learn what these tables, what information each table gives us, and how to find that information on the table. I think like little books like this, they claim it's easy reading. You know, they have published these tables in an easy reading format, but it is all the same information that they're getting. We just want to learn how to read all of these tables and what that information is. So our 3 tables that we're going to look at is, the first one is our daily tide predictions. Those are literally daily for certain places. Then we have table 2, our tidal differences, which I'll explain in a minute. And then table 3 is getting the height of tide at any time. So table 1 is telling us at 8 o'clock, it's low tide. At noon, it's high tide. At, 8 o'clock, it's a low tide of 2 feet. Noon, it's a high tide of 12 feet. 1600, high tide or low tide, whatever. It's telling us the time and the tide, But what if we want to know what the tide's going to be somewhere in between that, or how many feet we want somewhere in between? That's where we use table 3 to get any height of tide at any time. So the first table really just tells us the basic information, and then we use table 3 to fine tune what we're looking for. And again, we're gonna dive into this. Okay, so table 1 is your daily pages or your daily tide predictions, and these are for what we're going to call reference stations. So there are 9 reference stations in California. So there's not, a ton, right? The entire west coast of California, we only have 9 reference stations. Excuse me, hold on. So our reference stations, we have one in San Diego, one in LA. I think the other one closest to us is Monterey. Maybe, no, there's a closer one than Monterey. Port San Luis. So if we want to know what the tide is going to be at a more specific place, then we're going to need a little bit more information. But the daily pages, the information where it gives us, whatever day of the year, time and height, is going to be at our reference stations. And then table 2, we have this long list of subordinate stations. And this is where we get to, Newport Bay Entrance, that's a subordinate station. Balboa Pier, that's a subordinate station. Long Beach, El Segundo, Catalina, Avalon, these are all subordinate stations that are referenced from our reference station of LA. So on our table 2, we call it our tidal differences, and it's our list of subordinate stations. So we're really going for this column here that says differences. So it's differences in our time and differences in our height. That's the height of the water. Excuse me. So we have the long list of subordinate stations, and then we have our differences. And that's what table 2 is our tidal differences for subordinate stations. So when I kind of like to put things in an equation, that's the way my mind works. If we find the tide at a reference station and then apply the tidal difference, we will get what the tide is going to be at the subordinate station. So if our book said high tide is at 8 o'clock at LA at, 4 foot tide, and my tidal difference was and it's a half hour later at Newport, and it's only going to be, and I would subtract, you know, a half a foot or something like that. I don't know. I'm making this up. Then I see what it's going to be at my reference station. I apply my differences so that I can get what my tide's going to be at my subordinate station. And then I could go into table 3 if I want to. Does that make sense? We are going to be doing examples of this, so hopefully that will clear things up if you're confused by table 1. Table 2 gives us the tide at our subordinate station. Okay, so table 3 is our magic table. It's just one page here. It works for all of, it's going to be the same table 3, whether you're East Coast, West Coast, whatever. So our table 3 has 2 sections. It has the top section here. Oh. Okay, so I guess that my point on this slide here is table 1 tells us a time and a height, a time and a height. This third column here that table 1 tells us is in centimeters. We're not going to work in centimeters. We're just looking at the time and the feet. So if we want to know something in between, whether it's something in between on the fee side or something in between on the time side, we go to table 3. So table 3 has 2 sections. The top section is all about time. So we have kind of these corrections that we'll get to apply to the time side of our question that we're looking at. And then the bottom half is all about the height or the feet of the tide. So this is top half about the time of the tide. Bottom half is the feet or the height of the tide. So we can keep that in mind when we're navigating. Then we're going to have some of these terms. So I'm just going to go over these terms. Again, they'll make a little more sense when we do a problem. But our first one is duration of rise or fall. So this is in the top half, meaning it has to do with time. So how long did it take for the tide to rise? Did it take your typical 6 hours? Maybe it took only 4 hours. Or I think Brian was telling us, he was in class, that it was like 20 hours or something. So we have the duration of rise or fall, whether you're falling or rising, consecutive tide, and that we're going to get in hours and minutes. So how long did it take to rise or fall? Did it take 4 hours, 10 minutes? And here we're just going to round. You're just rounding to the nearest. So it's in hours and minutes. We have our H and our M. So that little H and M, I always like to point out if we get confused on what these numbers are. It tells us it's in hours and minutes. Then we have time to the nearest high water or low water. That's going to be on this side of the chart here. So this is what is nearest. If we have a tide at 8 o'clock and a tide at noon, and we're looking for the tide at 9, which tide is nearest to us? It would be the 8 o'clock tide, the one that is literally nearest. It'd be, you know, before or after. So which one is nearest to us? And we calculate that that time difference in hours and minutes to how close we are to the nearest high or low. Again, we have the hours and minutes to give us the hint that this is in time. I will shorten this to TNT. You might hear that in other YouTube videos or other ways of learning your tides that they call it TNT. So time to the nearest tide is essentially what that is. But time from the nearest high water or low water is what they are calculating, your TNT. Okay, and then in the bottom half, we have our range. Again, this is the range of the tide. Again, your consecutive range that you're going to calculate. And that is calculated in feet. So it is literally the difference, the height of the tide in the difference of the height of the tides in feet is our tidal range. Then we have the correction to the height. So this applies to that highest or lowest water, whatever one we went to before, according to time. We're going to according to feet as well. And this is the number that we're going to apply to our correction as our correction. And you'll see my graph of how to do this. So again, this is in feet. Our range is in feet. This whole bottom section is all about the feet, the height. I like to point out sometimes people get confused of whether they should add or subtract this correction. There is a note in the bottom of your table 3 that says what to do, but I'm going to show you my little method that really you don't have to check your note, but it's always good just to know that if you're super confused, it's there. Okay. I know this is going to make a little more sense to you once we start doing our worksheet, but does anybody have any questions on table 1, 2, or 3? Did that information make sense so far?
So Bree, that guy that got stuck in the Suez Canal, did he not have the tide tables?
I don't know. He must who knows? It could be anything, really. Could be anything. Okay.
So just one question, the table 3 that works for all locations, is that just based on the moon cycles that creates the tides on a kind of a consistent level on all locations?
Yes. So I want to say maybe Billy will know more about this whole like sine curve thing. So your tides are not linear. We can't linearly, we can't interpolate linearly. That's not a word. I don't know what the word is here. You can't interpolate like you can other things. We are using this table 3 graph for interpolation of the tide tables because our tides change slower at the beginning and then kind of peak out and go faster changing and then slower changing again. And we're going to see that in our rule of 12s, 12ths calculations. But table 3 is all about interpolating because we can't interpolate linearly. I don't know. You know what I mean.
So Bree, is table 3 used in conjunction with table 1?
Correct.
Okay.
Correct. We have to get the information, whether it's table 1 or table 2. We have to get the information of high tide or whatever low tide, high tide or low tide is going to be at this time, at this height. The next one is going to be at this time, at this height. I want to know what's happening in the middle. That's where I use table 3. So whether I
So
get
all of
those
these times, I'm sorry, all of these times, are they referenced in like your local time zone, or are they like Greenwich Mean Time, or what times are these?
That is a good question. Hence our next table of time. So actually, 2021 tide table is the first title book that I have seen that adjusts for daylight savings time. Most of them all go with your standard local time, not daylight savings time. But this one does go with daylight savings time. And I'm going to show you where you can see that on every single page. It tells you what zone description they're using. Therefore, you could you can know if your boat is on that local time as well. So what is the zone description your boat is observing, and what is the zone description the port you're entering is observing versus the book versus time is a big thing. So literally your boat can observe whatever time you want your boat to observe. Okay, let's look at time here. Yes. So we have time zones all across the world, right? And your time zones, we have GMT, Zulu, UTC, what's another name? There's lots of different names for our Zulu, I call it GMT, our GMT time, which is right on the prime meridian. So that's your England, Europe zone description of where your zone description is 0. And then we have 12 time zones on each half of the world. So if they start at the prime meridian, where do they end?
International dateline.
Yes, your international dateline. So if we divide up our 24 possible zone descriptions by our longitude, we get 15 degrees of longitude per zone description. So that's our 15 right here. That 15 degrees is actually centered on each central meridian of that zone description. So for Zulu time, your 15 degrees are centered on Zulu. So it's 7.5 to the east and 7.5 to the west of 0. Your next zone description is centered on 15, but it goes 7.5 to either side. So if your sun is right where this red dot is, noon, right? Your local apparent noon or sun is right above you, and you're at the central meridian of 0. Then if you're looking, where was the sun over here to the east? It was there, it has already passed because the sun is going to be traveling to the west, right? The sun sets in the west, rises in the east. So in the east here, the sun has already passed noon. It has already passed that peak, and then it starts to set. So over here in the east, that's where it's going to be 1 p.m. And then if you go one more over to the 30, it's going to be 2 p.m. One more over to the 45, 3 p.m., etc., etc. So we're in the west. So you can calculate what your zone description is going to be just by dividing your longitude by 15 and seeing which zone description you are in. There's also zone description charts, and then you also have our zone description maps. Because our countries are all different, our lines are not exactly straight like this, right? We have all these zigzaggy lines. Our international date line is not exactly at 180, right? It's kind of this zigzaggy line through different countries, I want to say property lines, but whatever. You know what I'm talking about. Okay, so you want to know what your boat's observing, what port you're entering is observing, and what your boat is observing. So let's talk about the West Coast here. So in the winter, we have our Pacific Standard Time. That is going to be zone description -8 with our central time meridian of 120. So if we go if we're at 120 and we go 7.5 degrees to the east and 7.5 degrees to the west, that whole section should be observing a zone description of -8. So we are at about 118, right? 118.30, 117, something like that. So we are definitely in that Pacific Standard Time. During the summer, or March to September, we observe daylight savings time, where we observe -7 as our zone description. So if we look at well, I think I'll show you on a slide here. So I'm gonna go back and say 20. If everyone looks at their 2021 LA tide table, at the bottom, it tells you your time zone. And it says local standard time, local daylight time, and it says the time is adjusted for daylight savings time. So this is the first time I've ever seen it say that. If it was not, if it did not say adjusted and our time zones didn't match up, we would be adding an hour. So if you are, I don't have it. I'm going to show you the 2019 one here. So if you are on the testing with the Coast Guard route or looking at older tide tables, down at the bottom, it says the time meridian is 120 west. 00 is midnight, 12 is noon. These times are not adjusted for daylight savings time. So in this case, we know that our 120 west is a zone description of -8, and I'm observing -7. I need to adjust one way or another. I want to say every instructor you have or person you might be talking about tides might have a different way of doing it. They might subtract an hour to the desired time or add an hour to this time. Both ways work as long as you are keeping straight what your zone description is. So I just teach it one way instead of going back and forth to a bunch of different ways to be confusing. All ways are right. There's no wrong way. But how we will do it is just by adding an hour after we figure out what our reference stations and subordinate differences are. We'll just add an hour to those times, and that can that will adjust for the difference in zone descriptions. If you are taking Coast Guard exams, again, for this class, this particular class, our 2021 tide tables are adjusted for daily savings time. So that's awesome. Okay, so we're going to go through some of the problems, do some examples on, it's not assignment number 2, it's assignment number 3. Pretty sure it's assignment number 3. It's the tide assignment. But then afterwards, we're going to do a quick review on how to calculate tides. Again, we're mainly focusing on tides and walking through those problems. I did do a current problem and recorded it. And we're going to do a quick review on how to calculate currents by the book. It's very similar, but just with some smaller tweaks, basically in the table 3 section. And then we're going to go over the rule of 12ths, which is the short and quick way. So we're going to go the long, tedious way of the book, and then we're going to look at the short and quick way of the rule of 12ths. So hopefully 7:15. I will get to this at the end. We'll get to as much as the tides as possible, probably at like 9 o'clock, go back to rule of 12ths here. So that's our plan. Any questions before we jump into the tide to the examples? Okay, let's do it. Okay, so again, my printer wasn't working, so I don't have the printer, but I have the digital assignment. So we're just roll with it. Okay, so number 1 is asking for the AM high tide in LA on January 26th. Can you guys see the whiteboard? That's what you're looking at, right? Okay. So we are going to go to our tide tables, to our LA section. So you should have a San Diego daily pages and an LA daily pages. So we want to be in the LA daily page section. And then we are going to go down to January 26th. So we have, and this is on the 26th, And on our daily pages, at the top, if you look at the top of the column, right under where it says January, we have a time and a height. So that's the time and the height of tide, and it gives us units. It gives us hours and minutes, and feet and centimeters. So just good to note what they're giving us here. So they asked us, what is the AM high tide? So if this is 2.4 and this is 5.9, this is going to be high, this would be low, this one would be high, low, and then this one would be high. So it doesn't tell us, oh, the 707 is the high tide, but it tells us the heights. So we do have to do a little mental thinking here. And when we're looking at somewhere to put the high tide and the low tide, we have to figure that out by looking at the tides. That makes sense, right? We got this, right? So the higher one is going to be the high tide, lower one, low tide. So our answer is 707. Our high tide, our AM high tide, will be 5.9. Our PM high tide is 2108 at 3.6. So I'm looking for a higher high than we want the morning tide. Then it asks us if we have a charted depth, our sounding reads 10 feet, what is the actual depth of water? So if we have our tide of 5.9 and our sounding of 10, actual water depth is going to be 15.9 feet. Pretty straightforward, right? Okay. All right. Now we're going to add some more complication. But that one's straightforward. We got that? Okay. We're looking for the afternoon low water and high water at Newport on February 11th. So Newport is not a reference station. We have San Diego and LA. So we need to go to table 2 to find the differences at Newport. So everyone go to table 2 and find Newport Bay entrance. They are in geographical order. So if you find Southern California, Okay, so it is on page 232. Did we find it? Yep. Okay. So we're going to go back to that formula that that I go to for reference plus the differences gives us our subordinate station. In this case, our subordinate station we're looking for is Newport. So I'm going to go to my Newport here. So Newport, we have the actual position, and then we have our differences section. This is what we're looking for, our differences. Then we have some average ranges and then an average mean tide level. So this is just kind of average information for you if you're doing some voyage planning, but this is going to give us more accurate information for our differences. So we have two kind of sections in our differences. We have the time for high water and low water, and then the height for high water and low water. So I'm just going to copy that format here. And say we have time, high water, low water, and then we have height, high water, low water. And then I'm just going to straight up copy those numbers that they gave us. So they gave us minus 0.003, minus 0.004, little asterisks, that means multiply, and another multiply. So let's write those in. Oops. Make it a big mess. Multiply 0.98. Multiply 0.98. So I just wrote in the differences for my subordinate station of Newport. Now, one more thing on this page. I want to know what the reference station is for this particular subordinate station. So, whatever our subordinate station is, then we go up to see what the reference station is. So this is telling us Los Angeles on page 8 is our reference station. So if we were looking at San Clemente, their reference station going up is San Diego. Everyone see that? How one's listing under your reference station. Excuse me, sorry. So I like to make a note of that and say my reference station is LA on page 8 if I have to go back to it for something. Okay, so now I'm going to go to page 8, reference station, Los Angeles. And I am looking for February 11th. So let's see.
What does that dot mean?
The bigger circle under the TH, that means, what does it mean? Full moon or new moon? It's telling us the moon. That would be full moon. Okay. So this is for February 11th. I'm just drawing it out here so we can see it together because it's hard to look on the paper. Okay, so I'm just going to make a mental note here. We have a low water, a high water, a low water, and a high water. The question asks us, what is the afternoon low water and following high water? So we are looking at our PM section, meaning these numbers. So we're going to grab these numbers and put them into place on my little chart here. So I have 1533 as a time for low water. So I'm going to write in my time for low water is 1533. My height for low water was negative 1.3. Then my next time was 2156, and that was high water. My high water was 4.3. So we had to do some little mental game here of where I put these numbers from my table 1, from my reference station. Where do I put them in my little chart here? So we just got our low water, high water, low water, high water. All right. So then we just apply our corrections or our differences. So in this case, we subtract just 3 minutes. So we get 2153. This case, we're subtracting 4 minutes, 1529. This one we are multiplying, so that little star meant multiply. So then I like to rewrite it again in case we go to table 3 in chronological order. So I can say, okay, at 1529, the tide was negative 1.27. This is my time. This is my height. And then at 2153, my height was 4.2. So if I'm looking for something in between, I can find that. But this is my kind of chronological order of my subordinate station of Newport. So, as you can see here, our difference for Newport is very, very small, right? We are pretty dang close to our LA, to our reference station. So when you look at a little book like this, they're giving you the daily pages for Los Angeles. They're giving you the reference station. So great, that will totally work for us in Newport because who cares, 3 or 4 minutes, like 0.1 of a foot, right? But if we are in an area where we have a bigger difference, then this little book is not going to be as accurate. Okay. Does that make sense? Okay. Let's do another one before we take our break. Oh wait, well, there's a part 2 to this. Okay, so if the channel depth is if our depth is reading at 20 feet, what will our actual depths of water be? So we're going to apply that. So if we have a 20-foot channel, we're going to apply our numbers to each. So this one is negative. We came across our negative tide. So it doesn't mean we're seeing the ocean floor, right? It just means it's shallower than the charted depth. So we can go with 18.8. Go on the safe route, call it 18.7. And then our high tide would be 24.2. So that's our actual water depth for a 20-foot channel with these tides.
Looking at the chart, Bree, I was just glancing at it. You would need something more, a different scale than just the big chart we have, right? Because it goes up to it's like 13 feet, I think, right at the entrance of the channel. But I don't know, is that we would need to see a little more detail than the big chart, right?
Yes, you do. And it says on your chart, use 18754.
Okay, so that's the chart.
So it's giving you a new chart for a different scale.
Okay, that's what I was looking at. All right.
Okay. But you would apply these numbers to whatever chart you're using. Okay. Let's do. You guys good? I'm gonna erase it.
Question, which one would be more accurate for like Long Beach Shoreline Marina? Would it be Long Beach Terminal Island or Long Beach Inner Harbor?
So, I would actually plot those. It gives you a lat and long next to the subordinate station. Do you see that?
Yeah, I see that.
I would plot that one and see where your boat is. Is it closer to which one? So what was your question on it? Terminal Island or Inner Harbor?
Right. Shoreline.
For shoreline? I would. What's our next one? Let's see. Where's my Long Beach? Something close to 11. I would say the Inner Harbor would be closer.
Excellent, thank you.
Okay. Oops. Okay. So number 3. We're looking for afternoon tides, December 26th at Los Patos. Okay. Okay, so we're looking for Los Patos, right? Yeah, Los Patos. And I'm gonna find the differences. So we're in Huntington Harbor. And here is an example where our differences are gonna be much greater than what we saw at Newport. I didn't write in. And what is our reference station going to be for this one?
Los Angeles.
Los Angeles. So we still have LA on page 8. Okay, so I wrote down my tidal differences from my table 2. And then I got my reference station for LA. So this is what I see for my reference station of LA on December 26th. And now I want to find the times and the feet to put in to my chart here. So I have a high water, a low water, a high water, and a low water. And I'm looking for my afternoon tides. So that is going to be these tides. So I'm going to put in my high water is 1348 at 3.8 feet. My low water is 2040 at 0.8 feet. So I just got that information from my reference, from my table 1. Daily pages. Did I get my numbers right? Okay. Okay, so then we apply our numbers to get subordinate station. So we have 1448, 5221, so I'm going to rewrite mine to say at Los Patos, this is Huntington Harbor, 1448. We have a 3.2 foot tide and 2152 is 0.5.
Why is there such a big difference between Huntington and Newport?
I think this is just the way that the water moves into Huntington Harbor versus Newport. I'm not exactly sure where they get all these differences from. I want to say it's mostly location. So wherever this subordinate Latin long is, at that place, there is a bigger delay with the tide change than there is in Newport versus the tide change at the Newport Bay entrance. Maybe, you know, Newport Back Bay is going to be more delayed than Newport Bay entrance, but we don't have a subordinate station for the Back Bay. So it's just good to be familiar that, one, there are subordinate stations. Where are those subordinate stations and how much are the differences? Are they not that much? Do we not really care? Or are they pretty significant? So if we're fishing or whatever, boating in an area that has a significant tidal difference, then we know, going off of our little handheld, it might be a little different. But if you're using one of those, you know, tide programs, apps, or you can just plug in what's the tide at Huntington Harbor, and it will already give you this tidal correction. It's already doing that math for you. You can print out a full, you know, tidal graph for Huntington Harbor if that's mainly where you're navigating, or for Newport, or for wherever. But this is the reasons behind our electronic programs. Okay, so Why did I get the answers so wrong from my answer key? Did anyone catch my mistake? Maybe these answers are old.
They're probably using last year's
Yes.
2020, December 2020, not 2021.
Let's see. What did I do? Yeah, the answer sheet is wrong. Cancel the answer sheet. My answer right here is right. I will update that answer sheet. Sorry about that. What do we got? It's almost 55. Okay, let's take our 10-minute break and come back around 8:05. And we're going to get into using table 3. So we're going to dive into the next part of tides. All right. See you guys in 10 minutes. All right, so let's keep on going on our assignment. We're going to introduce our table 3. You know what? I'm going to see if my printer will work for this. Okay. Okay, so in this question, we are working from a reference station, which is nice. Let's write in, so February 14th, LA. We have here, we have Okay. So I call this trying to find the times that sandwich our desired time. So we're looking at a desired time of 21:05. So we're trying to find which two times will sandwich those two. So we have our 17 and 23, which are before and after our desired time. So those are the numbers that I'm going to use. So I'm just going to rewrite this with those numbers. I can remember what those numbers were. We had 17:02 at 0.0, and then we had 23:24 at 4.4. Okay. So we want to know what's going on at 21:05. This is my question. So we can't do our linear interpolation. So we're going to use our table 3, height at any time, to figure out what the height is at any time. So we need to figure out 4 things, essentially. We want to figure out the duration between rise and fall. We want to figure out the range. How much of a rise and fall are we going to get? And then we want to know time to the nearest and our correction. So is our 21:05 closer to 17:02 or 23:24?
23:24.
23:24. So we want to know the time to the nearest tide, which is going to be that high water, and then we'll have our correction to that same tide. So we're looking for those kind of these values here, if you will. So we're going to have to do a little math. So I'm going to start with the duration. So that's going to be 23:24 minus 17:02. What does this give me? 6. So 6:22. And then I'm going to get my time to the nearest tide. Two 19. And then for my range, since we're going from 0 and rising all the way to 4.4, our tidal range is 4.4. So I don't have this, but now that is going to be my missing piece of information from my table 3. So did everyone get how I calculated those 3 numbers? Okay. So now we're going to use table 3. Zoom in here. So we're going to start at the top because the two things, I know it's zoomed in, the two things that we have are on the time side. So if the two things we had are on the feet side, then we start at the bottom. In this case, the two pieces that we have are on the time side. So we're going to start at the top of the table. And on duration of rise or fall, we're going to find 6 hours and 22 minutes. So we are going to be closest to that 6:20. Now, we're going to find time to the nearest tide. So that number is going to be 2 hours and 19 minutes. So we're going to go along looking for 2 hours and 19 minutes or something close to it. We have an exact 2 hours and 19 minutes. To see how I followed my chart here. So this number tells me that I'm going to be somewhere in this column when I look at the bottom of the chart. So I'm going to find at the bottom of the chart my range, which was 4.4. So we'll go with 4.5. And I'll go to my column that I know I'm in. And I get a correction to height of 1.3. So I'm going to go here, and I have a correction of 1.3. Oops. Does everyone get where I got that 1.3? So another quick mistake is to say, oh, the tide's 1.3. Got it. But there's still another step here. That's just the correction to the height. So if we know that at 1702 it was 0 and it rose all the way to 4.4, and we want to know what the tide was 2 hours and 19 minutes before that, am I going to add or subtract this 1.3?
Subtract.
Subtract it to keep it in this little sandwich here, right? That my 4.4 was my max and then it's falling again. So I'm going to subtract my 1.3. What do I get? I get 3.1 as my tide. So at 21:05, my tide is 3.1.
So Bree, we get all the math. So intuitively, what exactly does that mean?
Intuitively? That means
Yeah,
that
I mean,
you're
is this an
adding.
adjustment because of the moon? Yeah, I know, but I mean, what exactly is happening? Why are you doing this adjustment? Is it a moon cycle type thing, or what exactly are you doing here?
So the tide, let's see if I can get everything on one page. The tides rise and fall kind of like that, if you will. So sometimes you'll see people do their calculations where they say, okay, low water was here at 1702, and then it was here at 23:24, where does my 21 fall in? My 21:02. It's going to be closer to my high tide. So maybe we'll pull it over here, where this period of time in the tide, if we're looking at time, I guess, here, this period of time, from this period to this period of time, is where the rapid change happens. This is rapid change of the tide. So here the tide kind of slows down and bottoms out, and then slowly starts to rise. And then you get this rapid change, and then kind of slows down its rise, tops out, slowly starts to fall, and then you get that rapid change time. So that's why we can't interpolate this linear. It's not a linear interpolation.
The linear
So
would
why
be
is
if you
this
drew a
happening?
straight line.
Why is this
From the
happening? Is it a moon cycle type thing, or what exactly is causing this?
Well, there are the two things that cause tides are your sun and your moon. You have solar tides and lunar tides. And that's just the gravity of when you have the sun and the earth. The gravity of the water gets kind of pulled lopsided. Even though the gravity is between the sun, it still gets.
I get that. So this is what this correction is. These are solar and lunar tide corrections. Is that right?
Yes.
I'm just trying to intuitive. I mean, we've just been doing a lot of math here, but I just want to intuitively understand what is this correction for?
Yes, the solar and lunar tides.
So if I'm
Okay.
correct, it's not really a correction. You're just trying to find what the actual tide would be for a specific time
Correct.
between the high tide and the low tide.
Correct. And we can't do that like on a linear graph, because our tide graph goes like this.
Yeah. So the linear would be an average rate of change or a constant rate of change, whereas that's not what it is. It's a changing rate of change, I guess the term to say. Too many.
You're the math teacher. You get this.
Yeah, it's rates of change. That's what the curve is. Just the different speeds. You said it as speed, which it is. That's the rate of change, but same thing.
Okay.
So they've got it all in table form, so it's all just done. So we don't have to do the math, I guess. They've already done it for us in the table.
Yes. So if you're using an app or a website, it's going to give you the table with times at each, maybe on the hour or something. So there's less guessing involved, where we are finding the way the computer is getting their information to make your graphs.
For example, like the picture you showed where the boats are literally sitting on the ground next to the dock, you would need to know, okay, what's the latest I can get to the dock and still make it to the dock. It doesn't help you to know when low tide is because you're on the ground.
Yes.
So you need to know, okay, what time do I need to be back at the dock so that I can be moored up before the water completely leaves that area?
Yes. So one of our questions, so we're going to practice this and the other one in combination. And then we get to the question 9, what says where you're cruising El Segundo, you're looking for a low tide to clear a bridge. So you want that vertical clearance. When will it be 3 feet or less? So you're, saying, hey, when can I do that or have less of a tide? Does that make sense? So essentially for number 9, here's our bridge. Maybe there's some cars up here or something. Oop, there's a car. Okay. We're on a little boat. And we want to know when this tide, in order to get clearance that I've calculated from the charted, you know, the charted clear or the charted height of the bridge and everything, I've charted that I need my tide to be 3 feet or less. So if the tide, if the charted tide or the charted depth here is, here's the seafloor. Here's where your anchor is. Okay. If the charted depth is 10 feet, I'll make my boat different. Here's my boat. Are we seeing what I'm drawing here? Okay. So I need the tide to be 3 feet, because this is my my sounding, right? My sounding on the chart depth is 10. I need 3 feet or smaller in order to get clearance under the bridge. So when's my cutoff point? When is it like I can no longer do that because the tide is rising? Essentially. So those are kind of like more real world tide problems. And it would be easy to see that on the graph, but we're going to do it by paper, by chart, by math, and see why the chart or the graph says what it says. Okay. So let's do, okay, this one will be quick, another quick one here. We're on number 5. You're taking your family fishing in San Diego. So now we're on the San Diego page. What is the tide at 09:20 on August 8th? So again, we're using the reference station, so we don't have to do any subordinate corrections. We're just going to look at our reference stations to see what times sandwich our 9:20 on August 8th. We have August 8th. We have a 4:14 and a 10:37. So I would say those times will definitely sandwich August 8th. And we want to know what's going on at 9:20. So maybe 9:20 is, when we're pulling our lines, or that's when we've anticipated crossing the bar, or whatever. I don't know what it is. But we want to know specifically, what is the tide at 9:20? So we want to find our 4 things. Our duration, our range, and then we want to know time to the nearest. In this case, I can see easily it's going to be that later high water. And again, our later high water. So we're going to do our math to figure out those times. So I'll let you guys do the math real quick.
Do you need the dash on the times, or can you just put 623?
No, you can do 63 hours and minutes. Just that's not a time, right? It's not
Right. It's
623 or 623, however you're going to write it.
Right.
That's what, yeah.
6 hours, 23 minutes, yeah.
That's just my shorthand for not
I was just
doing.
looking at the symbol, yeah. I've been just putting 623. Okay, so the dash.
Okay, so we're going to go to table 3. I also wanted to note on our range, we had a negative range. So we went from negative to 0 to 4.5. So our tidal range would be 5.2. Everyone get that? Okay, cool.
Bree, I actually didn't. Can you do that just really quickly one more time?
Yes. So the tide is going, here's 0. It's going from a negative 0.7 up to a 4.5 and then back down again and doing whatever. So we want to know what is the total significant change here.
Oh.
So we're going to count when kind of like a timeline or a number line, if you will. We're going to go from 0.7 negative to 0 and then a 4.5.
I see. Thanks.
Okay. Okay. Okay, so our duration, so the 2 things that we have are time, so we're going to start at the top. Our duration was 6:23. So again, we're on that 6:20 line. And then we are looking for somewhere close to 1:17, 1 hour and 17 minutes. So we have 1:16 right there. So I know I'm going to be in this column. So then I'm going to go down to my range. And we're going to find 5.2. So we're closest to 5.0. And we get a correction of 0.5. That's our correction to height. So we have 0.5. Oops. So are we going to add or subtract that 0.5? Subtract. We want to keep it within the sandwich here because we topped out. This 4.5 was our high tide. So we're going to subtract, and we get a tide of 4.0 at 9:20. All right. So you guys more comfortable with your table 3? Had anyone used table 3 before this? Okay. So it's a little bit different, but just do it step by step and we can do it together. Okay, so on number 6, we're now going to put kind of these two things that we've learned together. Our subordinate stations and our table 3 work. So number 6, what is the height of tide in Manzanillo, Mexico at 0900 on October 11th? So tide is our question mark. 0900 October 11th. Manzanillo, Mexico. So we have San Diego and LA. So I'm going to say Manzanillo is going to be a subordinate station. So we're going to go back to table 2 to find Manzanillo. Let's say reference plus differences equals substation. Okay, so if we find our subordinate station, table 2, it's our first one here, where we have some of our differences. So I'm just going to copy down these differences right onto my table. And what is our reference station for this one, for Mexico?
San Diego.
San Diego. On page 4. So again, to find that reference station, we just follow it up until in our difference column, it tells us to go on San Diego, page 4. We'll go back to San Diego. We're looking for October 11th. Okay, so I want to find which times are going to sandwich my 9 o'clock. I'm looking for 9. So I'm going to say the 6, which is a low water, 6:19 and 13:01. Those are my sandwiching times. So I'm going to plug those into my reference station here. So my low water was at 6:19 at 2.8. My high water . Okay, does everyone get where I got these reference numbers and these difference numbers? Okay. Erase that. Now we're going to do the math. Plug and chug here. So now I like to write it chronologically so I can go to my table 2 or my table 3. So I'm going to say at 07:04, the tide was 2.3. And at 13:38, the tide was 3.1. Very small tide change here. And we are looking for what happened at 0900. So we want to find our numbers so we can go into our table 3. My math matching your guys' math? Cool.
No, but that's because you did yours right.
Sometimes I don't.
So you have to go to the closest time. That's why I went up to the 704. I got kind of in
Nearest.
robot mode. It just went down every time, but otherwise,
Yes.
otherwise you won't be able to find it on the table, right? It won't go that
Yes.
high.
Yes, you'll run off the table.
Yeah, that's
That
And
makes
then-
sense.
Yeah, and then you'd be like, why am I running off the table? Oh, this isn't the nearest one.
I gotta remember that little detail.
Yes. But the table won't work if you did it that way. So that's kind of like, hey, redo your math.
Okay, 634. That's it.
So what correction did you guys get?
Point 2.
0.2. And now we're going to add or subtract it.
add.
Add it. We're at a low tide rising to a high tide. We still got to fit in our little sandwich here. So we're going to add it to get 2.5. So our 0900, our tide will be 2.5.
Bree, isn't there a difference in time of the tides? Don't you have to factor that in too? Because according to the thing, it says Mazalan, the tides are, the high tide is 37 minutes later. So you would have to subtract that from 0900. You did, okay, okay, sorry.
We did that with this tide. So we're doing the 0900 of what's happening at the subordinate station.
Okay, gotcha, thank you.
So yeah, this is a little snapshot of what's happening at Manzanillo. And then you go to table 3. Okay. Let's see. I am going to let you guys do 7 and 8 for homework. Let's jump to number 9. And we'll do number 9 together. And then we're going to go back to the PowerPoint for our current and rule of 12ths. So we're going to jump to number 9. I'm going to erase this one. Okay. So we're at June 12th. El Segundo. We are looking for a time that the tide is less than 3 feet. That's not less than. Less than 3 feet. Okay, so let's look at June 12th, El Segundo. So El Segundo is a subordinate station. So we will need to do our table. In this case, our substation is El Segundo. Okay, what is our reference station for El Segundo? We're back in LA. Everyone understand where I got the differences written down from? Okay. So we're looking for a time. Did it give us an AM or a PM?
AM.
AM, an AM tide that is around 3 feet. So let's find LA on June 12th. Okay, I'm not gonna write it down. I'm just gonna bring this over here. Okay, so we have June 12th. And we're looking for an AM time that is 3 feet or less. So we are going to use the first 2 times. Yeah. What the heck? I'm looking at June 12th, right? at the other page? My answer key seems to be incredibly off already. Am I doing? This makes sense though. I feel like I'm still doing it right. June 12th. That's what the question said, right? June 12th. El Segundo. Okay, we're going with it. Our answer sheet is going to be wrong again. Where did I get those numbers? Okay.
Hey,
Oh.
Brady, don't you want to start from the day before? Because it's talking about the morning, and so theoretically your tide's going to be going down.
Very true.
So that might be where you're off.
Where I can't figure out what I did.
Well, because on the 11th, your high tide is at 2206. It's a
Yes.
5.8. It's going to be coming down. So that's going to place you at sometime in the 12th and early AM below 8.
Yeah.
And then you would have to do it. So basically you got to calculate it twice, right? Because you got a low tide at 0.05. Well, maybe. I mean, because you're looking for a 3.0, you know, you could just kind of round down. You're probably right at 3 right before noon.
I agree with you. My answer sheet somehow says that we have a tide range of 11 feet. So I must have been looking at the wrong page or something. We clearly don't have 11 feet anywhere. So we're going to kind of make this problem up as we go here.
You're kind of answering the question, what time would I need to get underneath the bridge by
Yes.
in the morning before it's too late, you know, the tide's too
high.
high before I can't get underneath it anymore.
Which is going to be probably pretty close to our 12:32 time. So it might even be in the PM, if you will. But we'll see. Let's do the calculation and see what it comes up to. So
You're
again,
probably not cruising earlier than 5:30 in the morning.
poorly written question. That is my mistake, my bad. Critique me all you will. It's a poorly written question because 3 feet is too close to the high and the low of that. But we already started this, so let's find the answer. Okay. We'll call it 2.6. I'm gonna edit this tomorrow to give us a better finding the tide at a certain time question, just to add to your homework list. But yeah, let's go with it. So at 05:52, we had a tide of that's a negative 0.48. And at 12:45, we had a tide of 3.26. We are looking for a tide of 3.0 feet, and we want to know when that is. So again, this is a snapshot of what's happening at El Segundo. And we want to find our 4, can't use green anymore, major things. I'm going to say this 3 is nearest to this 3. So I'm going to go here to here. We're still using that nearest mode.
Bree, I've noticed that sometimes you round differently and compared to this time for like Coast Guard purposes. Do you know if there's a
Coast Guard purposes? Yeah, it'll just be to the nearest 10th. So you would do 3.3 and 0.5.
Got it. Thank you.
Okay, so 12:45, 05:52. Okay. Everyone get where I got these numbers? Does my math check out? Okay, so now when we go to our chart, the 2 things that we have are on the feet side. So we're going to start at the bottom half of this chart and work our way up. So we had a range of about 3.7. So we can use 3.5. And then the correction we needed to get to that 3 feet was 0.3. So there's my 0.3. So I know I'm going to be in this column. So my duration was 6 hours, 53 minutes. That's going to be closest to 7. So my time to the nearest is going to be 1 hour and 24 minutes.
This is an example of where the rounding makes a difference, because had you rounded to the 0.5 and the 3.3, you actually get the one next to it.
Okay. So, which one did I get again?
You got 1.24 or 1.2.
124. Again, poorly written question here, but also, with the Coast Guard answers, with a question that's so tight like this, it will be more spread out, your ABC answer key. So there is room, like some people like to try to interpolate between these two numbers and try to like really fine tune it. But with the spread for the Coast Guard, your whatever you get calculated will be right. And they kind of do the calculations to the nearest 10th, so they'll probably give you that answer, the more rounded answer than the more technically accurate answer. Okay, but again, my question is not a good question here. I apologize. Okay, so this 1 hour and 24 minutes, am I adding or subtracting that to my 12:45?
Subtracting.
Subtracting. So I have 12:45 minus 124. 1, 2, 11. So I get a time of 11:21 is the latest time that I can clear this bridge. Anytime after that, I'm going to have a higher tide than 3 feet. Therefore, my mast is going to be touching the bridge. As the high water rises, my vertical clearance to get under that bridge gets smaller and smaller.
So like Darren was saying, there's going to be a period after from June 11th to 5:52 that's also going to be within 3 feet to find that range.
Correct. So this is, realistically speaking, are you going to be doing it in the later morning or are you going to be doing it earlier? Coast Guard speaking, you don't really know. You could look at the answers. Are the answers around noonish or the answers around 2300? And that'll clue you into which numbers to grab here. That's just a testing tip. Again, not really practical, just testing.
Oh, practically speaking, if you want to go fishing, you're going to get up early and you want to know when you can get under the bridge to get out.
You might want to calculate both of those on either side. Okay, I want to get to the PowerPoint and the rule of 12ths. So let's do that. But I am going to be working on this tomorrow. And again, revising the answer sheet and the questions. Making sure my 2 that we didn't do don't have errors, because apparently my brain was someplace else. Okay. There we go. You guys got the PowerPoint, right? Okay. So, what we have just been working on is calculating currents, or excuse me, calculating tides. So there's a whole nother book for calculating current. And we're gonna look at the differences here on what the setup is. So on our table 1, on our daily pages for current, we have, instead of having a time and a height, we have 2 times, 2 columns of times. We have a slack water and then a maximum. And then on the not side, it gives us the velocity. So the 2 things we're looking at in tide is a time and a height. The 2 things that we're looking at in current is a time and a velocity. So that's the speed of the current. And then right next to it gives us an F and an E. What does the F and the E mean? Current.
Flood and ebb.
Flood and
I can
ebb.
end.
Yes. So we have at 6:18, we have a 1.7 flood. And then we go to slack. We go to 0. That's a 0 velocity at 9:15. And then at 12:12, we go to a 1.8 ebb. And then the ebb gets weaker and weaker until it gets to a slack. And then we get to a max flood. And then we go to a slack. So we're kind of like zigzagging through this 0, slack, and our maximum ebb or flood. So it's a little bit harder to read, I would say, than the tide one, where it's just a time and a height. But we're looking for our slacks and our maximum flood or ebb. So that's the difference on our table 1. For the direction of the current, they give us a direction for the flood and for the ebb at the location. And they also give it to us at the subordinate station. So we'll go to table 2, which is our list of differences and our list of subordinate stations. So again, it's that same concept of what's going on at the reference station, apply our differences that we get to get what's going on at the subordinate station. So it's that same graph that I do. In this case, we have more times. We have, here we go, blown it up a little bit. We have, our subordinate stations, and then we have our minimum before flood. That's going to be a slack. So what was the time of that slack? And then what's the time of the next flood? What's the time of the next slack, which is the minimum before ebb? And then what's the time of the ebb? So this one, when we draw them out, will be chronological. We want it chronological, going from left to right. And then we have our speed ratio. This is going to be that correction to the velocity. So we had time and then we had feet, right, on the tide. We're still gonna have time, but we're gonna have 4 entries for time. And then on our height side, it's our speed, and we're gonna put in our ratio. And our ratio is always multiplied. So it's kind of like that percentage or a ratio of what the given flood or ebb is at that location. And then here for maximum flood or maximum ebb, you can get a specific direction for that max or ebb. So for the subordinate stations, you can get your directions here and your times there. You got time difference, speed ratios, direction. Okay, for the table, our table 3 is just one single table. It looks like it's 2 tables, right? We have, if you look at it, there's a table A and table B, but you're only going to either table A or table B, depending on your location. At the bottom, it'll say, use table B for Deception Pass, such. For all other places, use table A. So most of the time you use table A unless you're doing something else. Anyways, our things that we have in table A, we have that interval between slack and desired time, and our interval between slack and maximum current. So this is where some people get a little confused too. So the top here, that interval between slack and maximum current, is kind of like the duration, right? It's that interval between our sandwiched times. From slack to the maximum, what are those times? What is the time difference that it took to go from 0 to max? Or from, you know, low tide to high tide to low tide, whatever it is. So the one on top here is kind of like that duration. And then instead of doing time to the nearest, we always do desired time to slack. So always desired time to slack, not time to the nearest tide. Always back to slack. Then we get a value here, and this is what they call a factor. When do they have these? Okay, we remembered those. Time to slack to the desired time. So the value that we get is going to be a factor, and we're going to multiply that factor. There we go. Multiply the maximum velocity by this factor. Okay, now I'm going through this, but this is what my format or my table that I've been using ends up looking like. And I did this problem, I recorded it, put it on YouTube, so you guys can click on it and watch me do it. But it's the same reference station, the correction or the differences. I used to use the word correction, but it's differences. And then you have your subordinate station. You have your chronological times. We had a max flood, a slack, an ebb. We applied our corrections, and we got what was going on at the subordinate station. The reference station had their maximum velocities. My correction ratio was 0.1. I always multiply it. So I got 0.03. And then I wrote in what the direction was. That's what those two values are. So then I do my same kind of sandwich graph. At 1437, it was a slack water. At 1901, I had a maximum of 0.4 knots ebb. What was going on at 16:15? So again, I get that kind of duration, or that's the time between the slack and the maximum. And then I always get my time to slack. And then I always apply my factor to the maximum. That is currents. So you could watch my video there. If you want to practice more currents, let me know. I can get some current questions for you. I also have here for you, it's on Google Classroom, but it should be on your handout too, extra practice problems. So the lapware practice problems have tide and current problems, but their reference material is the 1983 tide and current tables for the East Coast. I'm going to assume most of you don't have 1983 tide tables for the East Coast. So there is, I linked the reference, there's a digital copy for the training, Coast Guard training exam purposes. If you want to practice, you can use that digital copy. They have the 1983 tide and current tables at OCC if you want to, go to the library and do some extra work if you want. But anyways, up to you. Okay. Oh gosh, we have 5 minutes left. Quickly, rule of 12s. So the rule of 12s is going to be our quick and easy way to calculate what the tide is. So it's kind of this quick and dirty way instead of doing all this math or having an app. The rule of 12s was created for the classic semi-diurnal tide where you have 2 highs and 2 lows relatively the same and on average 6 hours apart from each other. So very predictable, 6 hour apart high and low tide. Unfortunately, California does not have that. We have a mixed tide. So our rule of 12s doesn't exactly work 100% of the time, but it's good to give it a shot. But just saying, keep that in mind. That's the rule of 12s with a little asterisk next to it. Okay, so the idea behind this is that from a low tide to a high tide, back to a low tide, is going to be 6 hours. So you have a low tide, 0, and then in the first hour, not much change, where in those middle hours, you have a lot of change, that rapid change. And that's what we're going to take into account here. So we kind of divide up that the whole rise or fall, either one, into hours, because on average, it's about 6 hours. Then we're going to divide up pretty much the rise in height into 12ths. So we're talking about this axis of the graph here is the 12ths part. So in the first hour, it only changes about 1/12. In the second hour, it changes 2/12 of the total range. The 12th is of the range. In the third and fourth hour, it changes 3/12. So that's our rapid change in the third and fourth hour after our low or high tide. And then it goes back to 2 and then 1. So we have this pattern of 1, 2, 3, 3, 2, 1. and those are 12ths of the range. So how we put that thinking into an example, we're going to dive right into this. So here's an example. We have low water at 2 feet at 0300. Oh, okay. And then we have high water at 9 at 8 foot. What will the tide be at each hour? So if we put in our range, our difference between low water and high water, the difference that the water will change is going to be 6 feet. So if I get 1/12, 2/12, 3/12, I'm going to put in, 1/12 of 6 feet is, it's only going to change 0.5 feet the first hour. The second hour, it's going to change 2/12 to get 2/12 of 6 feet is 1 foot. The third and fourth hour, it's going to change 3/12. In 1 hour, it's going to change 3/12 of 6 feet, which is 1.5. So the first hour, I hope I put this on here. The first hour from 3 to 4, it's going to change 1/12, which is that 0.5. So we only, at 4 o'clock, we can quickly say, okay, it'll be 2.5, but it only changes, it takes a whole hour to change 0.5 feet. The next hour, it changes by 2/12, so it's going to change 1 foot in an hour. So we get 3.5. The next 2 hours, it has that rapid change. It's changing 1.5 feet in 60 minutes, where that first hour, it only changed a half a foot in 60 minutes. And again, we go to our 3/12, 2/12, 1/12. So we're kind of putting a quick graph instead of really calculating. It's just a quick way to do this, that graph with the rule of 12ths. Does that make sense? That first hour, it changes real slow. Second hour, a little bit faster. Those middle hours, rapid change, and then it slows down again. Okay. Do we want to do, it's 9:30, but we can do an example.
Yeah.
Huh?
How do you actually do the calculation? Just take 1 divided by 12 and then multiply it times the.
Let's do the problem. I will show you. So number 10 on our homework. Wait, can you? No, I didn't do it. Okay, number 10. Let me get to it. Where's number 10? After looking up the tide information, you see 09 o'clock, we had a 3-foot tide. At 1500, we had a 7-foot tide. Okay, we have a obstruction at 3 feet. In order to safely pass this area, you want an under keel clearance of 7 feet. Using the rule of 12s, what is the earliest time you can make this passage? Okay. Under keel clearance. I don't know why I made it a G. Okay, so first, What is the tide that I'm looking for? Did I do the mental math? Okay, so if I need an underkeel clearance, so here's my boat. Here's an obstruction of some sort. I need an underkeel clearance of 7 feet. Okay, it doesn't exactly say underkeel clearance. It says that I need water depth to be 7 feet. So I must have already calculated my safe underkeel clearance. The obstruction is, what the heck? I'm looking back at this.
It doesn't tell you the charted depth of the water.
It doesn't tell me the charted depth of the water. You're right. Why doesn't it tell me that?
Well, don't use that chart, the obstruction as the depth of the water right there at the obstruction.
Somehow I've said this is an obstruction is 3 feet. Again, poorly written question. I'm going to rewrite this one.
So you would need a 4-foot tide.
The answer that I'm working for is you need a 4 feet tide. Clarify wording. Okay. We're just going to change this to, we need a 4-foot tide. Okay. So if I have 0900, it was 3 feet. And at 1500, it was 7 feet. What is my tidal range?
4 feet.
4 feet. So if I quickly do 1/12 of 4 feet, 1/12, 0.33 or 1/3. 2/12 is 0.6. 3/12 is 1 or 0.99. So I'm going to keep this in mind, and I am looking for a tidal change of 1 foot. So if the first hour I only change 0.33, I'm not going to get to another foot. Excuse me. The second hour, I would change 0.66, and that would give me the foot that I want. So I'm looking for a 2-hour change to get my desired 1 foot. So the time I'm looking for is 11 o'clock. I really explained this badly. I'm going to work on this tomorrow. I apologize, my brain is dead. We'll touch base on rule of health next week.
Wouldn't it be 12 o'clock? Because, oh, so you add as you're going up?
So at 10 o'clock, it's 3.33. And then at 11 o'clock, it's 4.0.
Yeah, it's cumulative, like compound interest, kind of it.
Yeah, sorry. Thanks.
Think of it from a business money standpoint. It's the only way my brain can wrap around that one.
Okay. Huh, my brain's dead. Okay, so next week. Next week is our last day, if you can believe it or not. I guess I don't have. So the homework assignment or our final exam is basically a voyage plan. So you're voyage planning and applying a tide and current. So it's going to go back to that vector triangle. So you have a voyage plan, kind of doing that same like one. You have 4 given waypoints, and you're going to apply your tide or your current to each leg of the route and plot your voyage plan out. And then, but mostly my lecture is going to be on GPS, and I'll touch a little bit on electronic navigation. And we're going to kind of use those terms we're putting in our voyage plan and seeing what those terms are on our electronic gear, essentially. So that's what we're doing next week. Hopefully I'll be more organized next week than I was this week. I did want to show, I have for the tide, this is my way of doing tides. Again, you can YouTube or talk to another instructor. There's a bunch of different ways of doing tides that all, they're all basically the same. Like, I'm not reinventing the wheel here at all. But the common, I would say the more common one that people do is do the tidal numbers on a chart, on a graph like this, rather than doing my little sandwich time, if you will, instead of like 08, 2 feet, 1500, 6 feet. What is the time at 09:45 question mark? Like, I do this little sandwich thing, but I would say most people, or if you YouTube it, you might see it on a graph like that. So 0800, 1500, where is your 9:45? So I just wanted to throw that out there, that you might see things differently. But if you want to go back to the way that I did it, I did put a little cheat sheet and steps of how to do it this way. So you could look at that. Also, you have the tide and currents lapware assignment. So I think there's probably like 20 more tide and current problems. Again, these are 1983 reference book, so you have to either go to the library at OCC or just look at the digital one on Google Classroom. Let's see if I have this final assignment here. I don't think I do. Nope, I would have put it out. Okay, so yes, the final assignment is a voyage plan. I'm not gonna go step by step through it. There is a video on it. But I will answer questions and kind of briefly describe a voyage plan. You can use, I made a chart for you guys to use as a little template, but you can use whatever one, if you already are using one, or maybe a logbook you got from West Marine has one, or you found a different one on the internet. You can use whatever one that you want to. But check them out. And we'll meet next week. Let me know if you guys have any questions along the way, and we can go over kind of a multitude of stuff next week. So, yeah. That's all I got for you guys. Sorry for going late tonight. But have a good week.
Thank you.
Thanks, Bree.